Okay, this time, i-apply natin yung mga diniscuss natin na formulas sa mga pag-solve ng problems. Okay, so considering these problems, past board exam problems. So, number 1, a steel tile rod must be made to withstand a pull of 5,000 pounds. Find the diameter of the rod, assuming a factor of safety of 5 and ultimate stress of 64,000 psi. Okay, so meron daw tayong tie rod. Okay. So, na merong force, pull. So, tensile yan. F. Okay, pinapahanap diameter. So, ano daw yung corresponding diameter considering factor of safety 5, considering yung ultimate stress na 64,000 psi. So, ano yung corresponding diameter ng cross-section? Okay? Okay, so solve natin. Given, meron tayong load, pull. So, ibig sabihin, tensile force equal to 5,000 pounds. Okay, then binigyan tayo ng factor of safety na 5. And then, the ultimate strength. So, tensile pinag-uusapan natin. So, ultimate strength in tensile, 64,000 psi or pound per square inches. Okay, find, pinapahanap, diameter. Okay, so, from formula, so, solution. So, simple stress lang to. Simple tensile stress is simply so ginamit nating symbol kanina ay sigma. So gamitin natin sigma is equal to tensile force divided by the perpendicular area. Sa case natin, ang tinatanong diameter. So meaning to say, obviously, ang cross-section niyan ay circle dahil diameter ang hinahanap. So pi over 4 diameter square, area ng circle. Okay, kaya lang, binigyan tayo ng factor of safety. So, ano yung factor of safety? By definition, factor of safety is so, gamitin natin yung symbol. So, gawin natin sigma. The ultimate strength divided by the allowable stress. Okay, so ultimate strength sa case natin, tensile. Okay, so meaning to say, the allowable stress o tensile stress is equal to ultimate strength tensile divided by the factor of safety. So, substitute natin dito sa formula. So, mangyayari, so, allowable stress is the ultimate strength in tensile divided by the factor of safety is equal to the tensile force divided by cross-sectional area ng circle, pi over 4 diameter square. Okay, so substitute natin yung mga given. So, given ba lahat? Given lahat, sir. So, ibig sabihin, so 64,000 pounds per square inches divided by the factor of safety na 5 is equal to tensile force na 5,000 pounds divided by cross-sectional area pi over 4 unknown diameter square. So, unit analysis, cancel yung pound. So, matitira square inches, square root, matitira inch. Okay, paki-calculate na lang. 64,000 divided by 5 is equal to 5,000 over pi over 4 x squared. Shift solve, ano yung magiging value? So, masasolve na value is 0.705 inch. Okay, pinakamalapit, approximately, balik na tayo sa question, pinakamalapit sa choices ay 0.71. So, approximately, diameter is 0.71 inch. Okay, so letter B. Okay, so we have this example problem for tensile stress. Okay. We have this copper column of annular cross-section has an outer diameter of 5 meters and is subjected to an axial load of 200 kN. The allowable compressive stress is 14.4 kilopascal. The wall thickness should be most nearly to what value? Okay, so meron daw tayong annular cross-section na column. So, for example, ito yung column. So, side view ng column. Okay, so may cross-section annular. So, pag sinabing annular, so meron kang butas sa gitna. Okay, so ang sabi, yung outside diameter daw or outer diameter, ito yon, is equal to 5 meters. Okay, so of course, kung annular yan, meron siyang butas sa gitna. So, meron tayong inside diameter, then thickness. Okay? Such that the outside diameter is simply the inside diameter plus 2 times thickness. Okay, so ibig sabihin, ano yung mga given natin? So, isa-isay natin yung given. Okay, given. We have this first. We have the outside diameter equal to 5 meters. Then we have this load equal to 200 kilonewton. And the allowable compressive stress, so allowable compressive stress is 14.4 kilopascal. So, pinapahanap wall thickness. Okay, solution. So, by formula, definition ng compressive stress is simply compressive force, which is given, divided by the perpendicular area. Wherein, we are given annular cross-section, meaning to say, yung cross-section or perpendicular area natin is equal to area ng malaking circle, pi over 4 diameter square, minus pi over 4 diameter small diameter. Okay? So, substitute. Given naman lahat. So, mangyayari. So, kaya lang, ang pinapahanap sa atin, thickness. So, para mas mabilis, para thickness kagad yung lalabas, ilagay ko to in terms of thickness. So, from this formula, outside equal to inside plus 2 thickness. Therefore, inside is outside minus 2 times thickness. So, substitute, we have this pi over 4 outside square minus outside minus 2 thickness square. Okay, so substitute natin dito sa formula. So, given compressive stress 14.4 kilopascal or kilonewton per meter square equals compressive force na 200 kilonewton. So, hindi natin pinalitan yung mga unit. Consistent naman yung unit. Divided by pi over 4 outside diameter square minus outside diameter square minus 2 times thickness. So, 2 outside diameter minus, So, outside diameter minus 2 times thickness square. Okay? So, ito. So, we have this mangyayari, unit analysis, cancel yung Newton, matitira square meter, square root. So, thickness, shift solve, pakitype na lang, 14.4 equals 200 divided by pi over 4 times 5 squared minus 5 minus 2t squared. So, mahalaga yung parenthesis dito. So, shift solve, Masosolve the thickness. Is equal to 1.14 meters. So, balik tayo sa choices. Anong pinakamalapit? Yung tanong naman niya is what thickness should be most nearly. So, approximately, pinakamalapit, 1 meter. Okay, so letter C. Okay, so next problem. Question number 3. A steel bar carrying 3,000 kN load is attached to a support by a round pin 0.3 meters in diameter. What is most nearly the average shear stress in the pin? So, sa figure, given yung figure, okay, obviously, shearing yung mangyayari. So, kaya lang, hindi basta shear dahil dalawa yung shear area mo. Dito, tsaka dito. So, yan na ngayon yung tinatawag na double shear. Okay? So, given. Saysay natin yung given. So, given. First given, we have this force. So, shearing area or shearing stress. So, of course, we have shearing force. 3,000 kilonewton. Supported by a round pin given in diameter 0.3 meters. What is most nearly the average shear stress? So, find shear stress. So, solution. We have this formula. Shear stress is simply shear force divided by shear area. Okay, sa case natin, yung shear area natin is simply circular. So, pi over 4, area ng circle, diameter, square. Kaya lang, double shear, so times 2. So, therefore, substitute, we will have shear force na 3,000 kilonewton divided by shear area, 2 times pi over 4, diameter 0.3 meter square. So, pakikalki na lang, equals, ilan yan? So, mangyayari, 21,220 kilonewton per square meter or kilopascal. So, convert sa megapascal. So, divide by 1,000. Magiging 21.22 megapascal. So, approximately, pinakamalapit sa choices, letter C. So, approximately, shear stress is equal to approximately 21 megapascal. So, letter C. Okay, so next problem. How many 5/16-inch holes can be punched in one stroke in a steel plate made of SAE 1010 steel, 7/16-inch stick using a force of 55 tons? The ultimate strength for shear is 50 KSI. So, kanina, pag meron kang plate, then gusto mong i-shear, okay? So, formula, shear area is pi diameter ng hole times the thickness. Okay, so given, saysay natin, given we have this diameter ng hole 5/16 inch, then thickness ng hole is 7/16 inch, and using a force F, so shear force 55 tons. So, pag ganyan yung spelling, walang E, yan ay English ton, which is equivalent to 2,000 pounds per ton. So, cancel yung ton, yan ay equal to 55 times 22,000 is 110,000 pounds. Okay? Then, given yung ultimate shear strength, so ultimate shear strength na 50 KSI, which is equal to 50,000 pounds per square inch. Okay, so formula, solution. So, pinapahanap number of holes. Okay, solution. So, we have this shear stress equal to shear force divided by shear area. Kaya lang, yung shear area mo, which is simply pi dt, pinapahanap gaano karami. So, times the number of holes. So, this is the number of holes. Okay, so substitute, we have this ultimate shear strength na 50,000 pounds per square inch is equal to shear force na 100,000 pounds divided by area, shear area, the number of bolt yung pinapahanap, number of holes, times pi, times the diameter 5/16 inch times 7/16 inch. Okay, so unit analysis, cancel yung pound, cancel yung square inches, unit less number of holes. So, pindot na lang, lalabas dyan, N is equal to 5.12. Okay, so take note from this relation, you can see na yung shear force mo is directly proportional sa number of holes na bubutasin. Meaning to say, mas maraming holes, mas mataas na shear force yung kailangan. Ibig sabihin, yung defined na value ng shear force mo na 110 pounds or 55,000 pounds or 55 tons, ang kaya niya lang butasin 5.12. Meaning to say, pag tinaas mo pa, say 6, kailangan mo na ng mas mataas na shear force. Okay? So, ibig sabihin, ang sagot natin dito ay round down. So, i-round down natin yung 5.12. So, the answer is use N. So, ibig sabihin, ang sagot natin dito is N equal to 5 holes only. Okay? So, letter C. Okay, so may mga ganitong problem, same problem, kaya lang nagbibigay ng factor of safety. Tanong, kailangan bang gamitin yung factor of safety? Hindi. So, marami nagkakamali doon. So, sa case na to, hindi mo dapat gamitin yung factor of safety kasi remember, sinisira mo yung material. So, hindi mo kailangan ng factor of safety. Okay, so number 5. A 2.5 inch diameter by 2 inch long bearing is to carry 5,500 pounds load at 3,600 RPM using a SAI 40 load oil at 200 degree Fahrenheit through a single hole at 25 PSI. Compute the bearing pressure. Okay. So meron tayong bearing. So, kanina, binigay na natin yung drawing. Given is diameter equal to 2.5 inch, length is equal to 2 inches, and the load F equal to 5,500 pounds. Okay, so find the bearing pressure or the bearing stress. Okay, so formula, solution. Bearing stress or bearing pressure is simply the bearing or the force divided by the projected area, bearing area, which is we have shown a while ago, or we have shown sa discussion natin, which is the product of the length times the diameter. So therefore, we will have force na 5,500 pounds divided by projected area, length na 2 inches, times diameter na 2.5 inches. So, pound per square inch, ang unit ng bearing pressure mo ay PSI. So, yan ay, pag dinivide nyo, 1,100 PSI. Okay? So, letter A. Okay, so next problem. A shaft is subjected to a steady load of 36,000 inch-pound at a shear stress of 10,000 PSI. So, meron ka daw shaft. So, drawing natin. Meron ka daw shaft na ang load ko. So, take note, binanggit dito load. So, pag nagmamadali ka mag-solve, pwede mong magamit na formula dyan, akala mo yung load ay force. So, pag tinignan mo, yung unit niya, inch-pound. So, yan ay torque. Okay, so, delikado yan dahil kapag ginamitan mo ng F over A, andyan sa choices yung sagot. So, ingat kayo sa board exam. Basahin mabuti yung tanong. So, tingnan yung units. Okay, so, yan ay torque. So, T equal to, so, given natin, 36,000 inch-pound. Okay, so then yung shear stress, so given yung shear stress ng material na 10,000 PSI. Okay, compute the diameter of the said shaft. So, pinapahanap, find diameter. Okay, so solution. So, compute the diameter. So, we have this derived formula kanina. So, mangyayari yung maximum shear stress, considering maximum shear stress allowable ng material sa shaft. For solid shaft, 16T over pi diameter cube. Okay, so, substitute. So, given lahat. So, we have this 10,000 PSI or pound square inch equals 16T, 16 times the torque na 36,000 inch-pound divided by pi d cube. Okay, unit analysis, cancel yung pound, natitira inch squared times inch cube, cube root. So, diameter will be ship solved 2.64. Okay, so dalawa yung may 2. So, hindi pwede yung 1/4 dahil mas mababa. Hindi niya kakayanin yung load na 36,000 considering allowable or maximum shear stress na 10,000. So, use diameter na mas malaki. Sumunod na malaki ay 2 inches and 4 inch. Okay? So, letter D. Okay, so last problem. A steel bandsaw blade is 0.7 mm thick. So, ito yung tsura ng steel band. So, nilagay ko yung figure, yung actual picture. So, find the value of the bending stress when the blade is passing around a pulley. So, nilalagay sa pulley during cutting na may diameter daw na 450 mm. So, binigay niya yung modulus of elasticity. Pag hindi binigay, okay lang dahil binanggit naman steel. Pag hindi binanggit, i-assume na steel. Okay? So, given. So, we have this given. Thickness is equal to 0.7 mm. Find the value of the bending stress when the blade is passing through diameter ng pulley equal to 450 millimeters. So, binigay niya na rin yung modulus of elasticity. So, hindi mo na kailangang isipin or alalahanin. 206,900 megapascal. Okay, pinapahanap bending stress. So, bending stress or flexural stress. So, find flexural stress. Okay, solution. So, flexural stress is given by formula MC over I. Okay? Kaya lang, wala ka namang binigay na width ng bandsaw. So, ang gawin natin, recall from strength of material, i-recall natin yung relation ng bending moment sa curvature. So, kung maalala nyo, 1 over radius of curvature is equal to bending moment divided by modulus of modulus EI, product ng modulus of elasticity times moment of inertia. So, substitute, meaning to say bending moment is simply EI over radius of curvature. So, substitute natin dito sa formula natin, derived formula, EI over curvature times C divided by I. So, mapapansin nyo, pwede natin i-cancel yung I. So, meaning to say, na-eliminate natin yung requirement na nangangailangan ng dimension ng cross-section. Okay, so ibig sabihin, flexural stress is simply E times C over radius of curvature. Okay, so sa case natin, pag drawing natin, parang ganito yung tsura niya. So, meron kang pulley, then may naka-roll. So, exaggerate ko na lang yung thickness ng bandsaw. So, pag may naka-roll na bandsaw, okay? So, ibig sabihin, yung gitna, ito yan. Okay, so pag tinignan ko dito, sabihin na to, expand natin, palakihin natin. So, ang itsura niya is ganito. Okay, so meron akong neutral axis. So, ito yung thickness. Okay, so ito yung distance. Ito yung neutral axis, yung nasa gitna. Neutral axis. So, yung distance natin, yung C natin is ito. So, wherein C is simply T over 2. Okay? Wherein, yung curvature mo naman, ang distance naman ng curvature mo is ito. Which is equal to R, or diameter over 2 ng pulley plus kalahati nung thickness nung saw. Okay, so substitute natin, therefore E is simply, nakita ko na, 206,900 megapascal times, okay, C na T over 2, thickness binigay 0.7 over 2 millimeters divided by radius of curvature, half ng pulley diameter na 450 millimeters. So, 450 millimeters over 2 plus kalahati ng thickness 0.7 over 2 millimeters. So, cancel yung millimeters, matitira megapascal pa rin. So, therefore, the bending or flexural stress is simply equal to 321 megapascal. Okay? So, yan yung accurate. So, ang ginagawa dyan sa choices, kaya mas mababa siya. So, ang sagot is letter C. Mas mababa siya dahil sa portion na to, dito, sa part na to, ang ginagawa is ina-approximate na lang. So, ang ginagawa, flexural stress is approximately E times C over diameter. So, nire-neglect yung thickness na to sa ilalim. Okay? Kaya, pag kinalculate nyo ulit yan, considering yung diameter na lang, ang lalabas 322 megapascal. Okay?